We are now going to do what's called solving inequalities. And I'm going to just talk for a second about that word solve. Because when we solved equations, the goal was to find the value of the variable that would make the equation true. That is still the same idea with inequalities. We're finding the value of the variable that makes it true, but it's not just a single value. It's going to be an entire range of values. And that's what those number lines help us see. Any numbers in this part of the number line would make it a true statement. So our instruction for all of these problems that I'm going to do right now is going to be solve the inequality and graph on a number line. So that's what we're going to do on all of these. So 2 steps. Every single one, we're going to solve and we're going to graph it. Okay, so here is the first one. So we have 5x minus 15 is less than or equal to 4x plus 36. So we're going to solve this just like we would solve an equation. There's not really anything different here, at least with this one. I'm trying to get my variables on one side, my constants on the other side, and eventually get it where it says x is less than or greater than or whatever, less than or equal to something. So I might start by subtracting the 4x from both sides. When I do that, this is going to turn into just a 1x, or just x. And I write the rest of it. Notice how it all works just like an equation would. Now I'm going to add 15 to both sides to cancel out this part. That leaves me with x is less than or equal to 51. There we go. That is our, what we would say is the solution. Okay, x is less than or equal to 51. Now to graph it, we can make a quick graph. And all you really have to do, what I would suggest, is you label negative infinity, positive infinity, and then just the single number that you are working with, right? All you really need is this. You don't need a whole bunch of numbers. Let's just put that one. So we're going to put 51. And then, just like we did previously, we're going to use this symbol to figure out what we're going to put on the number line right above 51 and where we're going to shade. So sometimes it's easier to start with where are you going to shade. It's less than or equal to 51, which means at the number 51, it's everything to the left. Everything left less than. But then we have to figure out what symbol are we going to put here. And you have 2 options. You can draw the circle and then ask, do I fill it in or not? The equal to sign means we would fill it in. So that would be one way we could do it. The other way we could do it, you remember? It's a bracket, a squared off bracket facing the left. So what does this show us then? It shows us that any number in this part of the number line, all the way up to and including the number 51, would be numbers that would make this original equation true. Pick any number you want and you will end up with a true statement up here. Now as soon as you pick a number that's larger than 51, even if it's like 51.1, then you're going to end up with a false statement. So that's what that means. Any of these numbers work as solutions to this original equation. Okay, here's another one. D over 11 is greater than negative 2. Go ahead and try this one. Solve it and sketch it on a number line. So I want to get this D all by itself. I only have one term on the left, a term on the right. I want to get that 11 gone. I'm going to multiply both sides by 11. So multiply this by 11 and multiply this by 11. Why did I do that? Well, I did it so the 11 would cancel that one, leaving only the variable. Greater than negative 2 times 11 is negative 22. And voila, that's it. It has been solved. D is greater than 22, which means in order for this this original equation to be true, I can pick any number that's bigger than negative 22. Any number. Here's what it would look like graphically. Negative infinity, positive infinity. Take the number we are working with, put it here. Negative 22 is right there. And then we're going to pick numbers that are greater than. So this side of negative 22. Draw your arrow, right? To show it kind of goes on forever in that direction. Now, what symbol is going to go right here on negative 22? There's no equal to sign down there, is there? So that means it's an open circle, or it can be a parenthesis. And what does that mean? It means we can pick any number we want. As long as it's bigger than negative 22, I can put it in there for D, and it's going to give me a true statement. If I pick negative 22, it's actually not going to give me a true statement because it does not say equal to. How about this one? This one is going to have a slightly different twist to it. Negative 0.2 is less than or equal to negative 0.8 plus y. So I scan this, I see 1, 2, 3 terms. 2 are on the right side of the inequality symbol. Here's my variable. There's only one variable in this. So let's get rid of this. So we're going to add 0.8. I did that to isolate the variable. So what do we have? We have 0.6 positive. It's less than or equal to y, because this thing's gone. So one thing you might notice about this one is that the variable is on the right, the number's on the left. Normally we can just sort of flip-flop them around when it's an equation, but when you have an inequality symbol, you have to be careful. It's okay to take this whole thing and flip it around, but when you do it, watch what happens. Pause it and see if you can find the really important thing that I did. What happened? The inequality sign flipped as well. Here it was less than, here it's greater than. Why did that happen? Well, notice where the wide end of the symbol is facing. It's facing the y. The pointy end is facing the 0.6. You have to have it consistent when you flip it. The wide end is on the y side and the pointy end is on the 0.6 side. So you can pick the whole thing up and flip it all the way around as long as you do the same thing with the inequality symbol. So y is greater than or equal to 0.6. On a graph that would look like negative infinity, positive infinity, 0.6. It is greater than or equal to, so we're shading where? We're shading this way with the arrow. And what symbol are we going to put? Circle that is it shaded? Yeah, because it's got the equal to. Shaded, or we can also put what other symbol? A bracket, squared off bracket, facing to the right. All right, one more. We're going to solve and graph 9 minus 2y is greater than negative 1. I need you to put a big asterisk, big star next to this one, because something happens in here that you really have to remember. So 9 minus 2y is greater than negative 1. So let's solve. I only see one variable term, so let's just keep that right where it is and get rid of the 9, that constant term that's over there with it. Again, I'm using the inequality sign as my dividing line between the left and the right side. So 9's gone. What's left? There's a negative in front of that 2y, right? Negative 2y is greater than, this is going to be negative 10. So here is the point where it becomes really important. What do you notice about the coefficient of y? All right, we've got our variable right here. What do you notice about its coefficient? That's right, it's negative. When you have a negative coefficient in your inequality, you then have to either multiply or divide both sides by a negative, right? in order to solve this, we'd have to divide by a negative. So when you have that negative coefficient right here, I'm gonna type this out right over here. So when you have a negative coefficient in an inequality and need to multiply or divide by a negative, you must flip the inequality sign when you do so. So, pull that over so we can see it. Let's even maximize, increase that font a little bit. I'm going to let you read that, process that. Think about what I said there and what that means. It means that when you divide both sides of an inequality by a negative or multiply it, when you do that, you have to take this inequality sign and turn it around, flip it the other way. Y is less than 5. We had to flip the inequality sign when we did that division. And and that's going to be a crucial thing that you do. So let's see what that would look like on our graph now. Y is less than 5. I think we can all do this fairly well now. We have our negative infinity, our positive infinity. 5, we can just stick right in the middle there. Which direction are we shading? To the left. So draw your arrow at the end, shade it all in, and then open circle or closed circle. Open circle, because there's no equal to sign. And then it's a parenthesis if you want to do it that way. And that is it.
I also need to add that some mathematicians like to use a different notation to show inequalities, and it's called set builder notation. And it looks more complicated than it is. So let's see. The notation looks like this. You're going to see this little squiggly bracket followed by an X followed by a vertical bar, and then something that looks like X is less than 5. And then another one of those squiggly brackets in the other direction. And what you'll be told to do with that is something like graph the set on the number line. Right? Graph the set on the number line. And the word set means a group of numbers. And so what this notation means is this is the variable that you're going to be talking about. And you're to graph all values of this such as, or such that, that's kind of what that line means, such that X is less than 5. And that is where you're basically just going to have your 5, your open circle, and you're shading everything to the left because it's less than, right? That's what that notation means. Graph all values of X such that X is less than 5. All you really are caring about is this part of it. I just don't want you to get confused when you see that slightly different notation. So that's what we call set builder notation.